Welcome to the session on conditional probability review exercises. The objectives for this session are to review previous topics through exercises, namely, understand mutually exclusive and independent events, determine whether two events are independent, and understand and use tree diagrams. Pause the video and have a go at these review exercises. When you are ready to view the solutions, press play. Before attempting the first exercise, we're going to take a look at some theory which will help us to solve it. So let's define mutually exclusive events. When events have no outcomes in common, they are referred to as mutually exclusive. And we also have that the probability of A or B occurring is probability of A plus probability of B. For mutually exclusive events, the closed curves in their Venn diagram do not overlap and will look something like the sketch you can see on your screen now. So we have the sample space S, we have the event A in one circle, and we have the event B in another circle, and there's no common area between the two. We will now take a look at the first exercise. So let's solve this. We're going to look at part A first. Let A and B be mutually exclusive events, and probability of A equals 0.3 and probability of B equals 0.1. Find probability of A or B. Let's solve this. For mutually exclusive events, probability of A or B equals probability of A plus probability of B, which equals 0.3 plus 0.1, which is of course 0.4. And now for example 1b. Find the probability of B but not A. Let's solve this. For mutually exclusive events, we have that probability of B but not A is equal to the probability of B. And this is of course equal to 0.1. And now for part C. Find the probability of neither A nor B. Let's solve this. For mutually exclusive events, probability of neither A nor B is 1 minus probability of A or B, which is 1 minus 0.4. And of course the 0.4 came from part C, which is equal to 0.6. Now let's take a look at some more theory. We're now going to take a look at independent events. When one event has no effect on another, the events are independent. In other words, if A and B are independent, then the probability of A happening is the same regardless of whether B happens or not. The multiplication rule can be used to determine if events are independent. So probability of A and B equals probability of A times probability of B if A and B are independent. Let's now take a look at the next exercise. Let A and B be independent events and probability of A equals 2/5 and probability of B equals 1/9. We are required to find probability of A and B. So let's solve this. For independent events, probability of A and B equals probability of A times probability of B, which is equal to 2/5 for probability of A times 1/9 for probability of B. which equals 2 out of 45. Now let's take a look at the next exercise. So let's solve example 3A first. The Venn diagram shows information about 3 A-levels taken by students in a form group. Find the probability that a student chosen at random is taking both maths and physics. So let's solve this. Now the probability that the student is taking maths and physics is 4, which is in the region of maths and physics together, as shown in the Venn diagram, divided by 25. This is the total number of students altogether. These numbers have all been highlighted in the Venn diagram. And now for part B. Determine whether taking maths and English literature are statistically independent. So let's solve this. Now the probability that a student is taking maths and English is 1, as highlighted in the diagram, divided by 25. And let's check now if the formula also holds. So the probability of maths times the probability of English should equal the probability that the student is taking maths and English. So the probability of maths is 9 out of 25, and the probability of English is 4 out of 25. So we multiply the two by one another, and that gives us 36 out of 625. Are these two equal? No. Since the two are not equal, the events are not independent. A tree diagram is used to show the outcomes of two or more than two events happening in succession. Let's apply this to the next exercise. Suppose a bag contains 4 red marbles and 3 blue marbles. A marble is taken from the bag at random and not replaced. A second marble is then taken from the bag. Here's the scenario in pictures. 4 red marbles and 3 blue marbles. We are required to find the probability that both marbles are blue. And in part B, we're required to find the probability that the marbles have different colours. Let's begin by drawing a tree diagram. We can either draw a red or a blue on the first draw. And again, on the second draw, we can either draw a red or a blue, as shown here. The probability of drawing a red on the first go is 4 out of 7. Once we have drawn this red, there are now 3 red marbles left in the bag and 3 blue marbles left in the bag. And so the probability of drawing a red on the second draw is 3 out of 6. And the probability of drawing a blue on the second draw is also 3 out of 6. Now, if we go down the blue route on the first draw, the probability of drawing a blue is 3 out of 7, as shown. But once we've taken a blue marble, we have to eliminate that from the bag. And so we have 4 red marbles left and 2 blue marbles left. So the probability of drawing a red in this scenario is 4 out of 6. And the probability of drawing a blue on the second draw, of course, is 2 out of 6. And of course we can cancel as shown. And now we can find the probability that both marbles are blue. So if we have both marbles being blue, we go down the highlighted route as shown in the diagram. Blue followed by blue. Therefore, the probability of blue is 3/7 times 1/3, which is equal to 1/7. And now for part B. Find the probability that the marbles have different colours. So how can this take place? We can either go red-blue or blue-red. So either this route, which is 4/7 times a half, or this route, which is 3/7 times 2/3. So we add those two probabilities as shown. 4/7 times a half plus 3/7 times 2/3 to give 2/7 plus 2/7, which equals 4/7. This brings us to the end of this session. If you have understood its contents, you should be able to understand mutually exclusive and independent events, determine whether two events are independent, and understand and use tree diagrams. Thank you very much for listening.